All right, so the first part here, we're looking at still section 5.4. This is the third part of it. Here, the third part of the assignment is you're going to be having a combination of problems. Some of them will be natural log of u problems. Others will be e to the u problems. So, like I said, this last part of the calculus curriculum, you have to be able to switch back and forth between derivatives and integrals. And that's what makes it a little bit tricky, but it's a good way to finish because it does force you to do that. So on the first one, we're just kind of reviewing what's the derivative of ln of u. Do we remember? Derivative of ln of u? 1 over u. And then we have to do times u prime. And the derivative of e to the u is pretty straightforward. We know that's going to be just e to the u times u prime as well. So that's just the chain rule. Okay? So we're going to be doing derivatives here on the first 4, and then the last 2 are integration. So we have to be able to switch gears. So see how when we do derivatives, we say it's going to be 1 over this times u prime. That's the chain rule. And when we do integration, we do the u substitutions because that's the inverse function. The chain rule and u subs are the opposite of one another. And so is derivatives and integrals. So in the first part here, it says to find the derivatives for numbers 1 through 4. So to do this one then, it's a very straightforward problem. It's just going to be, we have natural log of u, so it's 1 over u times u prime. What's u prime? 8t. And if you notice, we're going to have 8t over this and over this. Well, that gives me 1, 2, 3 terms. Every one of those 3 terms can be divided by 2. So I'm going to save myself some time and do that. Divide the top by 2, divide that term by 2, divide that term by 2. That's the same thing as factoring out a 2 of the numerator, 2 out of the denominator, and canceling. It's just a quicker way. And by this point, you should realize that that's an alternative method. Okay, on this one, another natural log problem. But we don't want to just start doing 1 over u times u prime. Because if we think ahead, that would be really complicated. So we want to try to think, what else can I do to this problem before I take the derivative? Expand it, yeah. So anytime you have a problem that has natural logs, you want to expand it first before you just start trying to find the derivative. Any questions on that expanding? We know multiplication turns into addition. We know to the 1/2 power comes out in front as a coefficient. And so now taking this derivative, the derivative of ln of x is 1 over x. This derivative, we bring down any coefficient that's just a constant, times the derivative of natural log of u is 1 over u. And then times the derivative of that u. Oops, not plus, times. And so now this is one term, all of this is another term. So I might as well go ahead and cancel this 4 and this 2. I'm allowed to do that because it's all in the same term. Okay, so now I would have 1 over x plus 2 over 4x plus 2. What can I do with all of these terms? Divide them by 2. So my best answer is 1 over x plus 1 over 2x plus 1. So that's a review of derivatives with natural logs. Now, sometimes the problems get a little more challenging, like number 3. We're still taking a derivative. But what are we going to have to use on this one? What kind of function are we having here? It's a quotient, isn't it? So when I'm taking this derivative, this is my f, this is my g. The quotient rule is f prime g minus fg prime all over g squared. So to find this derivative then, I'd have to do f prime, the derivative of ln of t is 1 over t, times g is just e to the t, minus f is just ln of t, and then g prime. Well, g prime, the derivative of e to the t is just e to the t, and then all over g squared. I've noticed a lot of people don't know how to square that, e to the t squared. A lot of people say this. They say, oh, e to the t squared. So here's what we're doing. We're doing e to the t, and we're squaring it. And a lot of people say, oh, okay, that's e to the t squared, like that. Not true. What is it?
2t.
E to the 2t. Here's why. This means e to the t times e to the t. When our bases are alike, what do we do with the exponents? Add them. So when I square e to the t, it's not e to the t squared, it's e to the 2t. This one's not difficult except for the algebra with it. Now, here's something we've got. This is one term, and we have a complex fraction because we have a fraction within a fraction. Anybody know how I can get rid of that t? Multiply by t, right, Kyler? So I'm going to multiply the top by t and the bottom by t. So when I do that, when I multiply this first term, the t's are going to cancel, and I'm just going to have e to the t minus this one. I'm going to have t e to the t natural log of t. See how I changed that order? You don't really have to. I just like to write it this way so I don't think it's like ln of t times like t squared there. And then I have this on the bottom. That's not the answer you'd see in the back of the book, though. What would they do? Multiply by what? No? They would. They'd factor out an e to the t. So they would make it e to the t, and then e to the t divided by e to the t is 1 minus t ln of t all over e to the 2t. Can we do any more with it?
What did this mean? Wait, why did you get rid of the t on the bottom?
I didn't mean to.
Okay.
Thank you.
Sorry.
No, you're good. Thanks. Is there anything more we can do with it? Can I cancel this e to the t and e to the 2t? What does e to the 2t mean? It's e to the t times e to the t, isn't it? So I have this e to the t, and this e to the 2t really means e to the t times e to the t. You said t a lot of times there. Can you see how those would actually be able to cancel? So what am I just going to have on the bottom then? Right. So this can cancel with one of those and leave me with just an e to the t. So now I've got 1 minus t ln of t all over t e to the t. That would be the answer you'd see in the back. Yay, we get to switch to x's. All right, so on the next one, how can I make this an easier problem? How can I rewrite that problem? Minus. I can just do this. I can write this as natural log of 3 plus e to the x minus natural log of 3 minus e to the x. If I rewrite it like that, it's pretty easy to do the derivative now. The derivative of natural log of something is 1 over that, and then I have to do times the derivative of that. I'm doing it a little faster than normal. On this one, the derivative of natural log of this is 1 over this, but then times the derivative of that, and the derivative of that is negative e to the x. Well, instead of having minus and negative, I could just make that a plus, get rid of that. And so this would be a good answer. The back of the book, you never know. They might get a common denominator. I don't recommend it. This is just as good. All right, let's review our integration now. So switching gears to integration. What do we do with integration? We have to do a u sub. All right, so what are we going to let u equal? You think the bottom? Let's think ahead. If I let u equal x to the 2/3, that derivative would be 2/3 x to the negative 1/3. Okay, if I let it equal the whole numerator, it's going to be e to, x to the 1/3. That derivative would be e to the x to the 1/3 times negative 1. You know what I mean? Like, it's not going to work. Yeah, just this exponent. So u needs to be just that exponent. And this is something, once you practice it a few times, then it'll just come to you. At first, it's hard to figure out what u should be. But look, if I take this derivative, what is it? Can you see why that was a good choice? That derivative is x to the negative 2/3. Do I have an x to the negative 2/3 there? Yeah. Isn't this it right here? That's really an x to the negative 2/3. So in order to get that x to the negative 2/3, I'm going to have to multiply by 3. So I'm going to have 3 times the integral du. What's my problem going to turn into now? Look, all of this got replaced. That's all gone with 3 to the 3 du. Then what is this going to get replaced with? E to the, what's that? U. So that very complicated looking problem just turns into this. And that's easy to integrate. What is the integral of e to the u? E to the u. So it's going to be 3e to the u plus c. See how I make this look the way it looked at the beginning? So instead of calling it x to the 1/3, I just call it what it was there. That's it. Looks difficult, but it ends up being very straightforward once we do that u sum. All right. So thinking about what we did in number 5, what do you think we're going to do in number 6? Same kind of thing. What's u going to equal? 4 over x. But how should I rewrite it so I can take the derivative? All right. So now when I take that derivative, 4 times negative 1 is negative 4. X to the negative 2. Can you see how x to the negative 2 is really in our problem? Because can you see how that right there is really an x to the negative 2? So this right here is just like this, but what do I have to do? Negative 1/4, right? So everything in the circle gets replaced with negative 1/4 du. So this is going to be e to the what? Just e to the u, right? That's just u. What do I want to do with these numbers? Am I going to put 1 and 2 here now? No, let's change these into u's. So u is 4 over x, right? So if I plug in 1, what's going to be this number now? 4. If I plug in 2, what's going to be this number? 2. Now we're ready to integrate. What's the integral of e to the u? E to the u. So I'm going to have negative 1/4 e to the u is going to be my integral. I have to integrate from 2 to 4. So I'm going to plug in which number first, top or bottom? Top. So my answer then is going to be negative 1/4 e squared minus negative 1/4 e to the 4th. That's our answer. In the back of the book, it would probably look like this. Okay? Remember, this is something I can check. You don't need to check this with me, but just let me remind you of this. I think it's so nice that we can check this. So what I do is I get this answer here. I want to know what that is. 1/4 e to the 4th minus 1/4 e to the 2nd. So there's my answer. But I also can put this into y equals, guys. Remember how we can do this? So we can do e to the 4 divided by x, and then that's going to get divided by x squared. It takes a long time to type it in. I do a zoom 6. Here's the way the function looks. Did I type it? Yeah, there it is. Okay, and so then I'm going to do second calculate, and I want to calculate the integral from 1 to 2, and I get 11.4 11.80. And so then if I look back at what I got here, 11.80, right? Can you write 11.80 as your answer? Why not? It's not exact. Okay. All right, guys, good job. So remember that you have